This is Gausby from CSC department. My topic is Principles and Applications of UV Visible Spectroscopy. Introduction to UV Visible Spectroscopy. UV visible spectroscopy is an analytical technique used to measure the absorption of ultraviolet and visible light by substance. It is widely utilized in chemistry, biology and material science to study the electronic transition in a molecules. The technique provides valuable information about the concentration and molecular structure of analytes. Principles of UV visible spectroscopy. The principles involves the interaction of light with matter where photons are absorbed by electrons in a molecule. When light passes through a sample, certain wavelengths are absorbed leading to electronic excitations. The resulting absorption spectrum is unique fingerprint of the compound being analyzed. Instrumentation components. Key components of UV visible spectrophotometer include a light source, a monochromator and a detector. The light source typically emits in the UV and visible range such as deuterium lamps for UV and tungsten lamps for visible light. The monochromator also isolates specific wavelengths of light before interaction with the sample, while injector measures the transmitted light. Absorption spectrum interpretation. An absorption spectrum is plotted as observance, whereas wavelengths revealing peaks at specific wavelengths. Each peak corresponds to specific electric transition within the molecule, providing insights into structure. The area under the peaks can be related to the concentration of absorbing species according to Beer-Lambert's law. Beer-Lambert's law. The Beer-Lambert's law relates absorption to concentration and path length described by the equation A equals to epsilon into C into L. Here A is absorption, epsilon is molar absorptivity, L is the path length and C is the concentration of solution. This is the fundamental in the quantitative analysis and allows for the determination of unknown concentrations. Applications in chemistry. UV visible spectroscopy is extensively used for quantitative analysis of colored solutions and determining reaction kinetics. It assists in the identification of compounds by comparing their absorption spectra to known standards. The technique is also employed in monitoring to purify the chemical substance and identify the impurities. Applications in biochemistry. In biochemistry, UV visible spectroscopy is used to analyze biomolecules such as proteins and nucleic acids. It helps in the assessing proteins concentration and purify by measuring absorptions at 28 nanometers. The technique also facilitates the study of enzyme kinetics and the binding of ligands to macromolecules. Environment applications. UV visible spectroscopy is used to monitor pollutants in water and air, providing essential data for environment assessment. It can be identify and quantify a substance such as heavy metals, organic compounds in various matrices. The technique supports regulatory applicants and environment protection efforts. Industrial applications. In the pharmaceutical industries, UV visible spectroscopy is instrumental in drug formulation and quality control. It assists in the validation of production process and ensure the consistency of active pharmaceutical ingredients. Additionally, it is employed in the food industry to analyze colorants and preservatives in food products. Advantages of UV visible spectroscopy. UV visible spectroscopy is a rapid and non-destructive analytical technique allowing for quick sample analysis. It requires minimal sample preparation, making it suitable for high throughput testing. The technique is cost effective and widely accessible with applications across various scientific fields. Conclusion and future trends. UV visible spectroscopy continues to evolve with advancements in technology, enhanced sensitive and resolution. Future trends may include the integration of spectroscopic techniques with data analytics and machine learning for improved analysis. The ongoing development of portable spectrophotometers will expand applications in fieldwork and remote analysis. Thank you.